Now in earlier sections when you were drawing number lines, you were actually graphing inequalities, but really just with like one variable. So if you graphed a number line, it might just go from -2 to 5, and then you close it in and do what we did in the previous section. And I point that out because that was with one variable. But then the new section is going to have two variables. And this is going to be the exact same as relying on the slope-intercept formula. So instead of having just a number line where we only are dealing with the variable x, we're going to have a coordinate grid where we deal with x and y. So go ahead and label that x and y, just to remind yourself of what we're doing. And the easiest thing to do with these is to just pretend that these inequality symbols are not even there. So at the very beginning we're going to do y equals 1/2 x plus 3. And if I go to graph this line, I'm going to have a y-intercept at 3, and then I'm going to go up 1 over 2, up 1 over 2. And I do want you to be a little bit like this is the first time you're graphing as you graph this one. So don't go and jump and draw this line just yet. And the reason we can't draw that line just yet is that we were pretending that these were equal. They are not equal. So if I were to draw this line, it would be inaccurate because it would say that these were solutions. And since they cannot be equal, that is not 100% true. So take your ruler and don't connect all these dots. Make a straight line, but make it out of dashes, so pick your pencil up as you go. And let me be more clear about what that probably should look like. Here I just drew a line and then used the erasing feature on this to try to show how it would be more of a dashed line. So when they are not equal, just like the way that with one variable you would draw an open circle, and then if it did include it you would draw a closed-in circle, here we're going to use a dashed line to show that the answers are not included. So we are not done with this because really we just drawn a dashed line. Well, what this means is that this can be greater than. So some people want to jump right in and be like, well, greater than, well, that's got to be above. So I'm just going to go in and shade this in because I can have solutions anywhere as long as it's above that line. And that's, pretty darn acceptable. But these get a little bit more complicated to where eventually you'll be looking at the intersections of different graphs. And I like to be able to test out different values. So let's test out 0. I have a red dot there just because I'm communicating where this is at. So let's plug in 0, 0. And this I do want you to write down. So write the word check. And we're going to check the coordinate 0, 0. So in the original inequality, I'm going to say, well, 0 is greater than 1/2 times 0 plus 3, which means that 0 is greater than 3. Since this is false, this means that 0, 0 is not a solution. So when I go in and I try to shade in a region, I cannot shade in here because we just found out that 0, 0 is not an answer. So lightly with your pencil now you're going to shade in every part of your graph above this. And make sure that that line right here is still clearly dashed. That's why you kind of lightly shade in, because if you go in and you get kind of crazy with your pencil, you'll end up shading this really dark, and then you'll go over the dashed line that you made, and you won't be communicating that there are actually not solutions on the border of this line. So this entire region ends up giving you infinite solutions to this inequality, and those are where this y would be greater than 1/2 x plus 3. Now, I wrote this in purple because I'd like you to show this for today, but it's probably something you're doing in your head and not even representing to your teacher. Let's be very crazy thorough just so that helps you get this new concept. So here is 0, 5. And I'm just marking that in red. 1, 2, 3. And I think I counted wrong. So there's 0, 5. Let me plug in 0 to this. Half of 0 is nothing. Plus 3 gives me 3. Keeping the symbol the same, and 5 over there. When I plug in the value 0, 5, well, that is actually coming out as a true statement, so I'm checking a point in the region that I've shaded. And I think that at that point, we can say, I'm confident that the work here is correct. So this is a new type of problem and combines a lot of older concepts. So if you're not feeling comfortable with this, make sure you're seeking the teacher out to coach you through it, or figuring it out from additional examples, and using Wolfram Alpha if necessary. In this graph it says x is less than or equal to -1. Now we have this less than or equal to deal. And just like before, we're going to try our best to ignore the fact that it says less than or equal to, because if you just view this as a regular equation, it'll be easier. So here's where you have to be like, well, x is going to give me a vertical line right here. And I drew this as a solid line, and I'm making this solid line a little bit darker than my other pencil writing, because if I shade in later, it's going to stand apart as the border. And just like in the last one, we drew our line, but we are not going to draw this one dashed. We're going to draw this one solid, because it includes those values because of the less than or equal symbol. Okay, now check this out. X has to be less than -1. So let's think of a value over here. Well, that would be like -1, 2, 3, 4, -6, I think. Yep. So is -6 less than or equal to -1? It totally is. So we would shade over there. And I know I keep on talking about these checks, and I don't mean to exhaust you with them, but I am going to also check out a value like 0 over here. And just like before, here where the x value of 0 is 0, where the x value is 0, we like to do things like 0 because they check out. 0 is not less than -1. This would be false, so I should not shade to the right side. I'm bringing up those different ways of checking it to kind of strengthen the understanding of how to do these problems. Okay, we have y minus 2x is less than or equal to -4. Now this is not in slope-intercept form, and because it's not in slope-intercept form, we have to do a little bit of work ahead of time. And that explains why I've presented you these problems in this arrangement. The left side of your page is usually where your algebra work goes, and then later on we'll have not just one but 2 lines that you end up having to graph, and then where they run into each other. So you might have to do work not just for 1 but 2 lines, and then the right side of your page gets used for the graph that you draw. And for these problems, I still like you drawing the graphs, because I think it's just a skill that's great to build up. But since this problem is here for us, we can just add 2x to both sides, and then pretend that that inequality is just an equal symbol. And whenever I've made a change to the original equation, this is kind of proof to me of why I need to always be thorough in my checking. Because if I'm not, I might forget that I made a change and go back to the original. We have a y-intercept of -4, and the slope increases 2 every time. Now, I think I'll stop there, because at this point I see where it runs into the x-axis, and that'll be clear enough. Should I draw my line solid or dashed? Answer that question. Well, you draw it solid because it's less than or equal. So I'm going to make a solid line as best as I can on this iPad. And I can even label this. Here's y equals 2x minus 4. I didn't do this in the previous problem, but I think it might make it more clear for us. And the difference is I have a less than symbol. So some people are like, well, I guess that means you have to shade in here. But I really hate having to erase a ton when I'm dealing with paper, so if I check 0, 0, let's see if that works or not. 0 minus 2 times 0 is just 0. And is 0 less than -4? It is not. So that means that this would not be a point on my graph. And if anything in this entire region doesn't work, and you haven't made a mistake, then you just know that everything on the other region would work. And here, if I wanted to, I could be like, well, how about trying out a value where I'm going to drop more stuff out, like where I would be at 0, -10. How about way down here? Let's try that out. 2 times 0 goes away, and then I'd have -10 for y is less than or equal to -4. That is a true statement. So now I am verifying that this is a value, and I know that I'm good. Number 4. Make number 4 an OYO problem. Should be relatively straightforward, and I'll put the answer up in a few seconds. A couple things to make sure you have accurate. Is your line dashed? Is it only dashed? And also make sure it's horizontal as well, because that's where y would be 4. Did you shade above because it was greater? In your head, did you try to check a value? And so if I tried 0, 0, where y is 0, 0 is not greater than 4. And with regards to what you have written here, this that I'm showing here is really all you need to show. We'll stop this video here before we do the other types of problems.